The trajectory line was already wrong before anyone admitted it. On the tracking screens used by NASA navigation teams, Pioneer 10's Doppler signal should have drawn a clean, predictable path away from the Sun. Instead, the plotted line kept sinking, slowly, steadily, as if something invisible was pulling the spacecraft backward through decades of perfect calculations. Every correction model was applied. Every gravitational adjustment ran through the system. The line still drifted. Mission analysts at JPL did not treat it as noise. They treated it as failure. Because the signal was too consistent to ignore and too small to explain, a few billionths of a mile per second squared, barely measurable, but persistent across years of data. And that is what made it dangerous. Because Pioneer 10 was not supposed to be guessing where it was, NASA's Deep Space Network, the same system trusted to guide interplanetary missions, was locking onto a signal that behaved like physics was suddenly breaking at the edges of the solar system. And the longer they watched it, the more stable the drift became. On the main trajectory graph, the visual anchor formed early, a clean predicted line, and beneath it, another line slowly separating downward. Frame after frame, year after year. No sudden jumps, no system errors, just a steady deviation that refused every explanation. At first, engineers assumed thermal recoil, electrical imbalance, instrument drift, something inside the spacecraft itself. But each correction only moved the problem sideways, not away. The Pioneer 10 Doppler signal kept arriving on time. Clean carrier tone, stable lock, no signal loss. Yet its interpreted motion suggested a constant, unknown pull toward the Sun. A ghost force embedded in the math. NASA analysts revisited the same assumption again and again. If the signal is clean, the physics must be wrong. If the physics is right, the signal must be contaminated. But neither option behaved correctly under long-term tracking. And that was the first hidden dependency nobody wanted to name. The navigation system did not just measure motion, it assumed the spacecraft had no memory of itself. Then the trajectory graph returned. This time with decades stacked on top of each other. The drift was no longer a subtle offset. It was a visible separation between prediction and reality, a clean model line above, Pioneer 10's actual path below, like two truths slowly pulling apart in the same space. And still, the Doppler signal stayed perfectly stable. That contradiction became the pressure point. If the signal was reliable, then something inside the spacecraft design was generating a force no one accounted for. Not from space, from structure, from heat, from asymmetry, from a dependency buried so deep in engineering assumptions that it never appeared in physics equations. NASA teams began reprocessing old telemetry, not for errors, for structure. And that is when the visual anchor changed meaning. The trajectory graph was no longer just a line. It became a measurement trap, a system that converted imperfect spacecraft behavior into something that looked like a new physical force. But the spacecraft itself had not changed. Pioneer 10 reappeared in the tracking data again. Same signal, same drift, same invisible pressure toward the Sun. But now the question was no longer where the force came from. It was what inside the spacecraft made measurement lie consistently in one direction. The answer started small: heat. Radioisotope generators on board Pioneer 10 were releasing energy unevenly, not symmetrically, one side radiating more than the other, a fraction of energy escaping as directional infrared radiation, enough to produce a tiny recoil, continuous, invisible, and perfectly aligned with the drift that had haunted the data for decades. A structural detail, not a cosmic force. And yet it had shaped every interpretation of deep space motion. The second time the visual anchor returns, the graph no longer represents mystery. It represents accumulation, a slow correction of belief that took decades to arrive. The drift was still there, but now it had a source that lived inside the spacecraft itself, not outside it. Still, the dependency was not gone. Because navigation did not model heat like this, it assumed symmetry unless proven otherwise. It assumed clean emission unless disturbed. It assumed spacecraft were passive objects in space, not active participants in their own measurement errors. That assumption had been carrying the entire interpretation system. And it was already wrong. As the third pass through the data arrived, engineers began to see the real consequence. Pioneer 10 was not unique. Pioneer 11 showed the same pattern, same drift, same signature, same hidden dependency. The system was not detecting a force. It was detecting a design bias repeated across missions. The Doppler tracking signal was not lying. It was faithfully reporting motion corrupted by unmodeled structure. The more precise the measurement became, the more it amplified the hidden imbalance. And that is where the pressure collapsed inward. Because every attempt to refine deep space navigation still depended on the same assumption, that spacecraft behave like perfect emitters of signal, that nothing on board reshapes motion at the level of measurement precision. The fourth return to the trajectory graph made that assumption visible. The clean predicted line was still there, but now it looked fragile, like a theory balanced on a detail too small to see. Beneath it, Pioneer 10's path no longer looked like deviation. It looked like exposure, a system revealing what it had never been designed to account for. And then the final dependency became unavoidable. The force was never external. It was embedded, not in space, in interpretation, in thermal design, in how motion was reconstructed from signal delay. By the time the correction models fully accounted for asymmetric radiation, the ghost force disappeared from the equations entirely. But it did not disappear from history. Because for decades, deep space navigation had trusted a signal that was more honest than the model receiving it. The spacecraft did not break physics. It exposed how easily measurement systems can manufacture physics when hidden dependencies go unmodeled. The last trajectory plot shows it clearly. No more drifting line, just convergence. Prediction and reality finally aligned. But the meaning had already changed. Pioneer 10 was no longer evidence of unknown force in deep space. It was evidence that precision itself can hide failure inside trust. And the graph that once suggested a mystery now reads as something else entirely. A warning built into a line we almost believed.